Okay, so we're given this setup. I'm going to be talking about the ideal gas laws, and we're looking at two different gases. So the two different gases are connected. Really, that doesn't matter. All that's telling us that they must be at the same pressure. So that's telling us that the pressures must be equal. So we're required to infer that because they're connected, the pressures must be the same. They're also able to freely mix, so that you can assume that the molar mass is the same for each of them. So they're made of the same gas effectively. So P is constant. And then we've got this side where I've drawn it slightly bigger. So I've got the volume of X. So this is gas X. This is gas Y. X is at 150 Kelvin. Y is at 300 Kelvin. And I'm looking at the ratio of the masses. Now, ratio of the volumes, so Vx has twice the volume of Vy, and then the temperature of Y is twice the temperature of X. So I've got that information as well. Now I need to accept that because N is proportional to M, the number of moles is going to be proportional to the mass because it's made of the same gas. So I can solve this. So basically the ratio of Nx to Ny is equal to the ratio of Mx to My. Because the number of moles, if it's made of the same gas, the number of moles is directly proportional to the mass. So I need to arrive at this point, and I can do that using the ideal gas law. So PVX equals NX RTX. That's true for the container X. Then for the container Y, PVY equals NY RTY. And now I can just divide those two. So I can divide those two. I want NX over NY, so I'm going to divide this equation by this one. So I end up with PVX over PVY, P's cancel, equals NX over NY, R over R, they cancel, TX over TY. Okay, so I get that situation, and then I can use this formula to say that 2Vy over Vy, well, that cancels out to 2, equals Nx over Ny. Ty equals 2Tx, so I've got Tx over 2Tx, so they cancel. So then I multiply this 2 across, and I get that 4 equals Nx over Ny.